Welcome to this video version of the REC Silicon Silane Training and Operations Manual. It is designed to be used in conjunction with your printed version of the manual. If there are any points that you're unclear on, please refer to that document or contact the numbers shown at the end of this presentation. REC Silicon is a best-in-class silicon materials manufacturer and a major player in the photovoltaic, LCD display, and semiconductor industries. As the world's largest manufacturer of silane gas, REC Silicon is unmatched in manufacturing, handling, packaging, and transporting silicon gases. We maintain our unique position with multiple manufacturing and loading facilities, as well as a large storage capacity at each plant, and a service-driven philosophy that puts our customers' success first. REC Silicon ships bulk silane worldwide. The container types available for silane shipment are cylinders, tonners, and 10-foot, 20-foot, triple 20-foot, and 40-foot ISO modules. REC Silicon has the world's largest silane gas ISO module fleet. Silane is a highly reactive chemical that self-ignites in contact with air and requires special handling. This video will cover 4 areas. First, we'll outline the general properties of silane gas. Second, we'll go over the layers of protection needed at a facility for the safe handling practices of silane. Third, we'll discuss receiving, connecting, and operating an ISO module. And then finally, we'll detail how to disconnect and return an ISO module to REC Silicon. Once again, this video is an overview. For more detailed information, please refer to your Silane Training and Operations Manual or talk to your REC Silicon Gases representative. Silane gas consists of an atom of silicon combined with 4 atoms of hydrogen. Not found in nature, it exists only under very specific conditions and possesses some unique chemical properties. At room temperature, silane is a gas, but silane can liquefy under normal ambient conditions at temperatures lower than its critical point, and from a large pressure drop, where the Joule-Thomson expansion cooling can cause a drop in temperature to the point that silane will start to condense. Silane's critical point is 26 degrees Fahrenheit, or negative 3.4 degrees Celsius. Above this temperature, silane can only exist as a gas. Below this temperature, silane's phase depends upon temperature, pressure, and density. Extra care needs to be taken when handling liquid silane. Therefore, an awareness of silane's critical point is very important in day-to-day operations. In order to handle silane safely, you need to understand its hazards. The primary hazard of silane gas is its flammability. And while there are many common examples of flammable gases like natural gas, propane, or hydrogen, silane is unique because it's pyrophoric. The term pyrophoric means that when it is released into the air, it can ignite without an ignition source. This pyrophoric behavior is not typical of most flammable gases. As an example, propane burners or heaters require a pilot flame, sparks from a flint striker, or an electrical discharge to start the propane gas burning. When silane is released into the air, it may ignite without an ignition source. Another thing that makes silane unique is its very broad flammability limits. Flammability limits are the concentration range of the flammable gas when mixed with air that will support combustion. Propane, for example, has flammability limits of around 2% to 10%. If it's below 2%, it's too lean to burn. If it's above 10%, it's too rich to burn, even with an ignition source. By comparison, silane's flammability limits are 1.4% to 96% when mixed with air, and it maintains its pyrophoric nature between 2.5% and 96% over nearly all of its flammability range. You can see from this comparison of silane with propane, a gas that most people consider relatively flammable, that silane is perhaps better characterized as an extremely flammable gas. While released silane is dangerous when it ignites and it burns, it can be even more dangerous when it doesn't. Silane is an unpredictable gas and does not always ignite immediately. Spontaneous ignition depends upon the geometry of the release, line pressure of the release, and the environment it is released into. For example, silane may not ignite immediately if it is released from high pressure at high velocity. When the released silane does ignite, sufficient silane gas may have accumulated that an explosion can occur. Silane's unpredictability means that even under the same release conditions, different results may occur. There are 5 things that can happen. 1. Nothing. 2. Brown or white powder formation. 3. Intermittent popping sounds. 4. Immediate ignition fire. And 5. Delayed ignition fire or explosion. The explosion can be even more violent if it occurs in full or partial confinement, such as inside a building or a cabinet with insufficient ventilation. In addition to silane's flammability and explosion hazards, silane can be explosively reactive with other chemicals and classes of chemicals. For example, silane is explosively reactive with oxidizers such as nitrous oxide or hydrogen peroxide, and halogens such as fluorine, chlorine, bromine, and with certain halocarbons such as CFC12 or CFC22. This list is not intended to be all-inclusive. In general, silane should not be mixed with any other chemical unless you are absolutely sure of its stability and reactive behavior. Otherwise, the results could be deadly. Correct handling of silane is critical for both your safety and your company's success. So here are a few things to keep in mind when working with such a highly reactive substance. Before performing any work, wear the appropriate personal protective equipment, or PPE for short. Proper PPE can help prevent injuries from silane hazards such as flames, radiant heat, thermal burns, and hearing damage. Proper silane PPE includes fire-resistant clothing, thick leather gloves, a hard hat, safety glasses, and safety shoes. When breaking into a silane container or process, you should always assume silane is present. An additional PPE should be worn, such as earplugs, fire-resistant hood, and face shield. Hearing protection is necessary because even tiny releases can cause pops or small explosions that can be harmful to your hearing. When simply operating equipment that contains silane, it is not necessary to wear the face shield, flame-resistant hood, or the hearing protection. However, when breaking into a process, always assume that silane is present. How the silane end-use or transfer facility is designed and constructed can significantly impact safe operations. The facility should be designed to the best engineering practices according to ANSI and the CGA G13 standards, and should be reviewed by a team of experts. With this in mind, there are several key areas to pay attention to. These include security, location, construction, detection, emergency shutdown, mitigation, and emergency response. Access to the facilities should be restricted to qualified personnel only. The facilities should be manned or monitored 24 hours a day. The facilities should be located outdoors, and the recommended setback distances should be accounted for. The facility should be located away from occupied buildings, high traffic roads, physical hazard fluids, and incompatible materials, or acceptable engineering barriers should be installed. The system should be constructed using stainless steel tubing, valves designed for silane service, welded connection fittings, or otherwise acceptable mechanical connections, such as VCR or DIS. Silane is typically handled as a gas. Handling silane as a liquid requires special precautions, because if liquid silane is trapped into a confined area and then vaporizes or expands, overpressurization can occur. To mitigate this hazard, handling silane as a liquid should be avoided. Engineering controls such as heat trace should be installed into the piping system to ensure that silane stays above its critical point, 26 degrees Fahrenheit or minus 3.4 degrees Celsius. The facility should be designed with detection safety systems, such as silane detectors, set to shut down the supply of silane at 10 parts per million, and flame detectors that are also interlocked to shut down the supply of silane. Additional safety measures can be used for additional risk reduction for outdoor facilities, but must be taken if the facility is located indoors. These include explosion control, remote video monitors, smoke detectors, heat detectors, and oxygen sensors. Automatic shutdown and mitigation should be provided if silane or fire is detected. A remotely located, manually activated shutdown control should be provided, and additional shutdown devices should be located at each exit. Shutdown control needs to be provided in order to stop the flow of gas at its supply and at its point of use. Adequate ventilation is always important, but it is especially critical in the event of a silane release. An indoor facility should be equipped with a system that provides constant airflow of 150 feet per minute or 0.8 meters per second across all mechanical connections, and enough ventilation for 6 air changes per hour or 1 cubic foot per minute of floor area. Because fire is the primary danger of silane, adequate fire emergency equipment is vital. Working fire hoses, extinguishers, and automatic deluge systems are key components. Fire equipment must be tested regularly. If it doesn't work the first time, there may not be a next time. The facility should be designed to vent normal flows and concentrations of silane, and there should be a plan in place to address venting or transfilling emergency quantities of silane. Vent lines should be continuously purged with an inert gas at a velocity of 1 foot per second to prevent oxygen from entering the vent line. The inert gas system should have a low pressure alarm to indicate a loss of supply, or an auto purge system requiring certain pressure set points to complete an operation. Any facility that uses silane or other hazardous materials must have a detailed emergency response plan. Such a plan spells out who's responsible and the procedures for directing and supporting emergency operations, communicating inside and outside the plant, ensuring rescue and medical services if needed, and handling other issues such as plant security and notifying regulatory agencies. All emergency responders, including off-site responders, need to be trained on silane, the containers, and the site layout. Appropriate equipment needs to be used, including bunker gear and SCBA, or self-contained breathing apparatus. In the event of an emergency, every silane facility needs a well-maintained alarm system and fast, easy-to-use communication systems. Communication systems such as phones, radios, and intercom systems are all cost-effective ways to allow a fast response, when a few minutes can make the difference between a small incident and a big problem. Facilities should have an evacuation plan in place, and workers and emergency responders should be drilled regularly to ensure the swift response that can save lives and protect property.
They're designed for safety for the responders that are inside the hot zone.
The basic precautions for working with silane are these. First, treat all silane mixtures as potentially dangerous and evacuate personnel from the surrounding area. Second, cool the containers with flooding quantities of water and allow silane fires to burn out. Do not try to extinguish them in any way, as that could lead to increased concentrations of silane and a possible explosion. Third, control the area around the fire with water, carbon dioxide, or a dry chemical extinguisher. Fourth, do not try to isolate an unignited silane release while you are in the area. Instead, use remote isolation. And lastly, never use halon fire extinguishers on a silane fire. Now let's take a look at the silane ISO modules themselves and the components you'll be working with. Each ISO module contains 8 to 12 high-strength carbon steel tubes inside a steel frame, all designed to meet legally mandated safety requirements. At both ends of each tube, a bull plug assembly is threaded into the steel tube. The bull plug houses a tube valve and, for some countries, a pressure relief device, or PRD for short. The PRD is designed to vent silane away from the tube and manifold in case of a fire. It is comprised of a high-strength stainless steel body that's welded onto the bull plug. The PRD is designed so it only releases in a fire scenario where there is both high pressure and high temperature. Inside the device, pressure relief is provided by a rupture disc, which gives way when pressure reaches between 3,700 and 4,000 psi-G, and a lead plug that melts at 165 degrees Fahrenheit or 74 degrees Celsius. After both the rupture disc bursts and the lead plug melts, the silane escapes through the tube vent, which is routed above the tubes and away from the manifold, allowing for less damage and better control. As you can see, both high temperature and high pressure, the conditions of a fire, are required to activate the PRD. The second connection on the bull plug assembly, The tube valve allows silane to the manifold and ultimately to the manufacturing process. When the tube valves are open, they allow silane into a stainless steel tubing manifold, which connects all of the tubes. Here, the manifold valves allow the flow of silane to the master inlet-outlet valve and onto the customer process connections on a tube-by-tube basis or all tubes at once, depending on your process. The manifold valves should not be used to regulate the flow of silane. They should either be closed or open. Flow regulation should be accomplished by using valves or an RFO, a reduced flow orifice, built into your manufacturing process. This system of valves allows operators to isolate individual tubes during shipment and use and during emergency situations. An automatic shutdown limits the source of silane in the event of a leak. What do you do when an REC silicon ISO module arrives at your manufacturing facility? Let's follow a team of silane operators now as they prepare to receive a shipment of silane and operate the ISO module. Prior to performing any work, review and follow the correct procedures and wear the appropriate PPE. Next, inspect the incoming ISO module to make sure it is carrying the proper placarding. Placards indicate the hazard and contents of the ISO module and are required by law. Be alert for physical damage to the ISO module tubes, frame, doors, and ISO module chassis. If you find any denting or deformation of the ISO module, you should stop and notify REC Silicon immediately. Light or superficial corrosion and damage need not be reported. Check to make sure that the car seal is in place on both the front and rear manifold doors, and that the car seal has not been tampered with. Carefully inspect the ISO module manifold content label ticket, which will tell you the manifold helium pressure and the loaded silane tube pressure. Note that the silane tube pressure can vary depending on the temperature. If the ticket is not in order, report this discrepancy to REC Silicon immediately. Verify that all manual valves are wire-tied and that the manifold's inlet and outlet CGA caps are present. Next, visually inspect the PRDs and bull plugs on both front and rear manifolds for evidence of silane leakage, as well as the valves and fittings on the rear manifold. The presence of either a fine white powder, silicon dioxide, or a fine brownish powder, silicon monoxide, indicates that silane leakage has occurred and should be reported to REC Silicon immediately. A portable silane detector, if available, is an even better way to detect small silane leaks. At the sign of any detectable leak, you should stop work immediately and report the problem to your supervisor. Now that we have inspected and accepted the ISO module, let's follow the same team of silane operators as they connect and later disconnect an ISO module. One of the most important safety techniques when breaking into a silane process is the two-person buddy system. In this system, one person performs the work while the other provides a safety backup. The buddy system provides an extra set of eyes for early detection of trouble, and if problems do arise, having a buddy present greatly enhances your ability to control the situation, get help, and ensure the safety of everyone. After inspecting the ISO module and prior to performing any work, place a jack stand under the ISO module to provide secondary support to the chassis. Install an engineering solution to prevent accidental pull-away of a connected ISO module. Use a chain with a lock and key, a glad hand lock, or a kingpin lock. If your process uses a key, place it in a secure location, such as on the module connection itself. Restrain or remove cabinet doors. And finally, be sure to install electrical grounding straps. First, open the pressure gauge isolation valve. At this point, the pressure gauge isolation valve will have about 60 psig of helium behind it. This might not register on the gauge due to the fact that the gauge goes up to at least 3000 psig. If the pressure gauge registers above 100 psig, this could be an indication of a tube valve gross crossport leak. When breaking into a silane connection, always assume silane is present. Remove the disc caps while using nitrogen to purge the connection. If silane is present in this fitting, the nitrogen allows for the silane flame to be pushed away from the operator performing the work,
allowing him to recap the fitting. Once the DIS connection is opened, visually inspect the connection for any damage or powder, and replace the old gasket with a new metal gasket. Align the piping so the connections are parallel and not under stress. Torque the CGA connection closed to 35 foot-pounds or 47 Newton meters with a calibrated torque wrench, being responsive to the break of the wrench. Inert process gas panel and connection point, vacuuming up to the master outlet valve. Check for vacuum loss. If none is observed, brake with inert gas. If vacuum loss is detected, stop and notify REC Silicon. Remove the black vapor-tight cap from the Twin-Tech Master Pneumatic Valve air connector. Ensure master air is off and all manifold valves are closed. Align notches, thread on Twin-Tech connector, and hand-tighten connection. Each numbered port corresponds to a numbered tube on the ISO module or master inlet-outlet valves. Apply air pressure, recommended at 100 psig, up to a maximum of 115 psig to the pneumatic system. Keep the tube valves closed and open master inlet and outlet valves and open all manifold line valves. Inert the manifold with helium to remove the oxygen to 25% of the LFL ratio, using pressure and vacuum up through both master inlet and outlet valves and the pressure gauge isolation valve. With the system purged, pressurize the manifold and connection piping to at least 1000 psig helium. The pressure gauge can be used as an indicator of pressure within the manifold. Leak check the module connections, both DIS fittings, manifold piping connections, all fittings, and valve bonnets. The best method is to use a portable helium detector to conduct the leak test. Now vent the manifold. After venting is complete, close the master inlet valve, or the unused side of the manifold. Vacuum the manifold to 1 × 10⁻⁻1 torr up to the tube valves. To unlock the pneumatic tube valves, allowing them to open, turn the handwheel counterclockwise until you hear a click. This handwheel must be manually unlocked before use and locked before return shipment. To break the manifold with silane, close the manifold valves and then open the tube valves. Keep in mind that pneumatic valves are quick acting and will apply full tube pressure immediately to the system. Now use the manifold valve to introduce pressure between the ISO module and connected piping. Pressure swing the manifold and outlet connection piping with silane for quality purposes to remove residual helium, moisture, etc. Establish flow by opening all critical isolation valves on silane used system. Once silane has been introduced in the system, working in pairs is no longer required. But when it comes to handling silane, 2 heads are definitely better than 1. An ISO module like this can supply a manufacturing process for weeks, maybe even months. As silane is used up, the pressure will drop until it is too low to supply your process. Tubes should not be allowed to lose all pressure. Closely monitor tube pressure during operations, and as pressure approaches 50 to 75 psig, or 446 to 618 kilopascals, prepare to change out the ISO module. REC Silicon requires at least 50 psig for safe transport and to allow our factory technicians to sample the silane in the tubes. Returning a module to REC Silicon is a 2-part process. First, disconnecting the ISO module. Second, filling out a customer module return status document. The purpose of this document is threefold. First, it serves as a checklist of the steps to ensure the proper items are completed before the return of the ISO module. Second, it increases the safety of our operators. And lastly, it ensures that we are aware of any problems with the ISO module and can safely handle it upon its return. This generic schematic illustrates the main points of the disconnection process. Be sure to adjust your procedure for your specific process configuration. Unless your process draws down all tubes simultaneously, thus ensuring equal pressure between them, you must first equalize the pressure in the tubes. While still connected to your silane process, close the master inlet-outlet valve on the ISO module manifold. Then open the 2 tubes closest in pressure and let these equalize. Then open the next tube closest in pressure and continue this process until all tubes are equal in pressure. Next, close all the tube valves by closing and torquing the manual valves, or by removing the air pressure and depressing the actuator and turning the hand wheel clockwise on the pneumatic valves. Properly closing the valves in the ISO modules is critical to ensuring safe handling, use, and transportation of silane. The manual valves must always be tightened to the specified torque, according to the valve reference sheet located in the rear ISO module cabinet. A torque wrench is the only way to ensure a valve is correctly tightened and should always be used. If too little or too much torque is applied to a valve, it could allow silane to leak by and possibly result in a dangerous fire or expensive plant shutdown. Leaving the manifold valves in the open position, open the pneumatic master inlet-outlet valve, and then open the valves to your disposal system, which will relieve pressure from the manifold and transfer lines. When the manifold pressure is relieved, close the valve to the disposal system and retorque the manual tube valves. Pressure swing the manifold using nitrogen or helium. Remember to keep the pressure gauge isolation valve and the master inlet-outlet valve of the unused side of the connection open to ensure the entire manifold is inerted. Repeat the purging process several times to bring the silane concentration below 25% of LFL at a minimum. Once below 25% LFL, vacuum swing the manifold with nitrogen or helium. Then repressurize the manifold to about 50 psig, or 446 kilopascals with the inert gas, and close and torque all manifold valves, including the pressure gauge isolation valve. Also, remove air to both the master inlet and outlet valves. Vent the inert gas pressure in the pigtail connection and isolate the connection from the process lines. Now you can disconnect the manifold from the process lines. Remember to replace the gasket at the dis outlet connection with a new metal gasket before capping and torquing the connection to 35 foot-pounds. With the process lines disconnected, you may now prepare the ISO module for shipment back to REC Silicon. First, immobilize each manual valve by tying it with sturdy wire as shown.
Next, make sure you've completely filled out your customer module return status document.
Your company name, the number of the module, and the date go at the top. Then fill in the pressure and contents values for each tube, and record the torque value used on each manual tube valve, or indicate that the actuators are locked on the pneumatic tube valves. Next, report the manifold pressure and the inert gas used. Note the status of the manifold line valves and the master valves. Indicate that all manual valves were wire-tied. Record that new nickel gaskets were inserted and the inlet and outlet CGA caps were torqued shut, and the black cap was replaced on the Twin Tech. Record the car seal numbers from both the front and rear cabinets. Note any damage, as well as any additional comments you may have. Be sure to fill in your name when you've completed the document.
With the paperwork completed, the module is now ready to be shipped back to REC Silicon. When we receive it, our technicians will go over it thoroughly, check on any problems you have reported, clean and repair it as needed, and finally, refill it for shipment. In the event of an emergency situation within your facility, the following response actions may be taken. These recommendations are not intended to supersede procedures and plans already in place within your facility.
Prepare. Have a written plan of what to do for silane emergencies. This should include identifying the primary responders, preparing designated emergency equipment, and ways of venting or transfilling high-pressure silane. Identify. You should identify what warrants a response and call to REC Silicon. This includes 1. Brown or white powder visible anywhere on the ISO module. 2. Damage to the ISO module during transport that is severe enough to compromise its integrity. 3. Any detectable leak during incoming inspection or during use. 4. Major fire in the facility that could impact the ISO module. 5. Manifold pressure that is elevated above the pressure indicated on the manifold tag upon receiving the module and opening the pressure gauge isolation valve. And 6. Anytime something is unclear or seems out of place when handling silane from the ISO module. If there is a fire, 1. Isolate the area for 330 feet or 100 meters. 2. Initiate emergency shutdown of the system. 3. Initiate E-Squad and or call the local primary responders if needed. 4. Do not extinguish a silane fire directly, but try to isolate or depressure piping or vessel. 5. For small fires, after isolating the fire, control its spreading to structures and equipment with dry chemical or CO2 fire extinguishers. And 6. For large fires, isolate the area for up to 1 mile or 1,600 meters or as much as possible. Cool containers with flooding quantities of water. Containers can explode, or PRDs will relieve pressure at high temperatures. When cooling the containers, do not put water directly on leaks or allow water to freeze on leaks, as it may put out the fire and lead to an explosion. And always fight the fire and cool all vessels from a maximum distance, using unmanned hose holders, deluge, and monitors. In the event of an emergency situation within your facility or during transport, contact REC Silicon's 24-hour emergency response line immediately. The response line is staffed with Silane trained individuals who can offer assistance 24 hours a day. If your facility is within the U.S., Chemtrek is available for contact during emergencies.
We hope this video has been a useful guide to working with REC Silicon's Silane ISO modules. This video is to be used in conjunction with the Silane Training and Operations Manual and your company procedures. If there are any questions that have not been answered here, please refer to that manual or talk to your REC Silicon Gases representative. Thank you, and stay safe.